So yeah, so I think I will talk about a little bit about the Venice DIV data integrity validation. Um, with a basic it's a very going to be an introduction to this component, how it works, why we have it, what are the um, aspects of it. So okay, so at the high level, I think so why we need the DIV, right? So Venice have many components that will input data to the Venice. For example, we have the Vanish push job will write data to us. We have the nearline Samza push job will write to us, and also Venice itself, like the leader, will produce data to the from the RT topic and to the BT topic. So Venice itself will produce data to itself. So we need a way sort of the end-to-end data quality validation, and the DIV is used for that purpose. And so we want to validate and detect errors if there are any, or we want, a peace of mind if there's not. So the way it works is to the DIV is sort of a meta information that we encoded. And the way we can do that is like we have a full control of the Venice writer. So I think every component that writes to Venice have to use the Venice writer to write data. And there we will calculate and includes the metadata that used for the DIV. And also the receiver part, it'll recalculate and verifies the data on arrival. So that's how it works, sort of end to end. Okay, so then what are the main component that the metadata has? So the Venice writer, it won't transmit all the data, at one shot. It will basically chunk the data into multiple segments, what we call segments. And the Venice writer, has a way to say when I want to close the current segment and when I want to start the next segment. The segment will have a ID associated with that. So the normal segment will look like this. It has a what we call the control message. It's a special message other than the data message. It's called a startup segment, SOS for short. And also at the very end of each segment, we have the end of segment message. It's also a control message, EOS. And then in between, we could have other type of control messages or regular data messages. I'll show you a later example later so you can see it better. And also for each sender, there's another thing to identify each sender called a GUID. It's a unique identifier for each sender. It's generated by the Venice writer itself. One thing to note is that this GUID is not persistent in any way. It's just it just created in memory. So every time you restart a Venice writer or you restart a host, a server host or whatever the writer, then this ID will change. So it will have an impact later, as we will see that why we need some way to clean it up for the still states. And then
quick question. So Venice writer is the consumer of like the events that are coming in from the Kafka topics, right?
It's a producer. It produces to the Kafka. It's a write to the Kafka topic.
Oh, it's a writer.
Yeah, that's why I call Venice writer. It writes to the Kafka topic from the Kafka topic perspective. It's a writer to it.
Really? If we use Venice writer, will it automatically write start of segment, end of segment, or the caller has to write it?
I think it will. Like it's gonna be like you send something, it will have a it's a wrapper class, right? You send something, it'll send the message, the SOS at the beginning, then the end of segment at the end.
So caller will just have to write the actual data and all the metadata will be written like a GUID, all control messages.
Yeah, but you can't actually call a deeper function like send start of segment or send end of segment if you want.
If you want.
Yeah, but because it's like Venice Writer, I think it's very general purpose. It's had different levels of control.
Okay, for some purposes, we may want to write it.
Yeah,
take control of that.
Yeah,
Usually
you don't need to, I think. Okay, so then the sequence number. So within the segment, we'll have a sequence number associated with each message. It starts from 0 and goes, as long as the segment goes. Then okay. So example is like this, right? Here's a dump for the Kafka topic. It's starting from the Kafka topic offset 0 and until some arbitrary number that I just pick. And here you can see that we have there's a thing called producer metadata. That's where we store the DIV related informations, like the GUID, then the segment sequence, then the sequence number. So this is segment 0. It has 0, 1, 2, 3, and you see the start of segment, end of segment, and in between you see like 2 other messages, right? That's happen to be a control message as well. And then that's identify the GUID. This is is sent from the same Venice writer because the GUID is the same for the first 4 messages. Then then you see in the same Kafka topic, right after this 4 message, you will see a different Venice writer write to it, right? It's also have the start of segment, so topic switch, end of segment. Then even though the segment is the same, but the GUID is different. So it's I think it's a 0 segment for the other Venice writer. It's not coordinated within the same Kafka topic, but it's like for the other writer, they have different GUID, and you see it also goes like that. Then there's another, I think there's a third writer write to it. Start of segment, then you see a lot of like data message going on, and there we haven't seen the end of segment yet. The segment is still open, it's not ended. So that's kind of the flavor how if you dump a Kafka topic and you dump the metadata, you will see something like that. Any questions?
Yeah, I mean, not based on the DIP, but we have seen if there is topic switch, then shouldn't the reader switch to other topic? Then why there are puts after that? What's the?
This is I think this is a VT topic. The leader will switch to the RT topic, but it still consume from the RT, then produce those information back to the VT for the standby to consume. I think this is what happens.
I see. Okay. Mm-hmm.
Later puts also for a different GUID. The later puts are also for a different GUID, not the same one.
Okay. Yeah.
So like in that screenshot, after the topic switch and at the end of segment, we don't see any more messages from that producer, from that Venice writer.
That GUID.
Yes.
Yeah, the second one. Yeah.
Yes.
Okay. This one if you G status this one, probably it's a controller or something. Okay, so that's how it looks like. Like if you work or debug DIV related issues, then very often you have to dump the Kafka topic and look at segment sequence number and things like that.
It's a cert1 parent controller. I just checked it.
Oh, okay. Okay, so basically in Venice so that's how it looks like. So in Venice we normally have 4 type of DIV issues. One, so unregistered producer, that is when you see a segment that starts from a non-zero sequence number, so you don't see the start of segment. When you have that issues, when you see that in the dump, then we call it unregistered producer. And also there could be gap between two consecutive sequence messages, then we call that data missing. Then we could have a and also we maintain a running checksum. It's normally associated with the end of segment control message, and if the checksum doesn't match, I mean the producer, when it produces, it maintain this checksum, and also when the consumer when consumes, it also maintain a checksum. If this two checksum doesn't match to each other, then we see this segment is corrupted. And also there could have like duplicate messages, meaning that you could see like the sequence within the same grid, same segment, you see sequence 2 message twice or multiple times, then that's considered as a duplicate. So we normally have this 4 types of problems. Okay, so we have like different behaviors. So okay, when you see this problem, say let's say you our DIV verified and find a data missing problem. It could be a big problem, it could be a small problem. If it's a big problem, meaning that you see this before the end of push. The end of push is basically the control messages in the Kafka topic. Basically that's indicate the batch push period is over. So if you see any data issues before the end of push, we normally consider as a big problem. The BPJ should be failed or something like that. So you know, it's more, it'll fail the BPJ push job and kill the push job and wouldn't have the version ready to serve. So that's more serious. That also, like after the end of push, is probably mainly the nearline data comes in, and that when we see the problems, we normally just logs the warnings and have a matrix to show this happens. And we wouldn't actually kill the version, the serving version, because the version might already serving real traffic. So we wouldn't kill the version, do anything harm to it. So that's kind of the difference. The end of point, the end of push thing. Okay, so the DIV have several data infrastructures involved. If you look at the figures here, the sender part, we have the Venice writer for sure. That's where the thing we use, the class we use to produce data to the Kafka topic. And there's also, as you can think of, the message health itself has a metadata embedded somewhere in the Kafka message. And also the receiving side, we have like DIV to consume the data and also to keep track of the metadata and throw any errors out if it sees anything horrible happen. The core infrastructure is the segment, right? The segment is per so Venice writer is normally one Kafka topic or one store version has a corresponding Venice writer. It's a 1-1 mapping from the manifestor to the Kafka topic. Then there they maintain different segments for each partition have a segment, and there you will see the segment number, sequence number, checksum, those values. And the same thing on the receiving side, we also have the segment data structure that's for verification purpose. Yeah. And, the producer metadata is the one that we keep this information on the Kafka record. Right. And here, like for each ICT store ingestion task, we maintain a consumer DIV and a drainer DIV. It's a little bit confusing. Later, I will explain why we have the two DIV currently. What is the rationale behind it? But that's how it looks for the data structure. That's all the data structure involved, I think. I hope no questions.
So it's only validate until we actually have consumer.
Oh, by the way, that's a good question. By the way, this is for I'm mainly talk about in terms of the Venice server's point of view. I think maybe controller also consumes, but it's a different. I'm talking about here is basically the DIV has a lot of. I mean, if it had any issues, I would assume that 99% is like on the server side. So I just use this for this is a Venice server sort of architecture structure. But to your question, the consumer task where the consumer thread we will actually use or leverage the consumer DIV, and the drainer DIV is actually used by the drainer thread. We have like two stages. Like if you look at our ingestion pipeline, we are like two stages. Like consumer thread consume the topic from the Kafka and write it into a internal buffer. Then the drainer will drain from the internal buffer to the disk. So it's I don't know if I answer your question,
but why do we need to have two DIV? Like why? What can be wrong between the first checkpoint and the second checkpoint that the drainer needs to verify?
I think I have a section.
Okay.
It's coming.
Okay, thank you.
Okay, so and also for like internal for all this DIV state, we actually persist the DIV state into our checkpoint. Our checkpoint is a big envelope, but we put the DIV information in it. And the reason I think it's quite clear that the server can restart. Then when it restarts, it go back to some point in the history in the Kafka topic, and we have to maintain if you still want the DIV to work without losing any internal informations, then we need also the DIV state to be checkpointed as well. So without checkpointing the DIV, then either you have a very inaccuracy validation mechanism, or you have to consume it from the very, very beginning of the topic so that you rebuild the DIVs, message by message and keep it updated. So that's, why we want to checkpoint the DIV as well. Then I think the next big topic is to your question. It's why we have two DIV instance and why we want to do it twice in consumer ones and in drainer ones. So as I said, we have a two-stage pipeline for ingestion, right? The consumer thread basically consumes the message from the Kafka topic and do one time of DIV validation, and then write the information. If there's anything wrong, it'll yell, and then it'll put the data into our internal queue. I think, store buffer service we put into our queue. And then the drainer is also, it'll dequeue from this buffer and run its DIV one more time, and then persist the data into the storage engine to the checkpoint to the disk periodically. There's small difference here is that the consumer thread or the consumer DIV, it'll only run the DIV for RT or remote VT topics. For local VT, it'll bypass. But for the drainer DIV, it'll run for all topics, no matter it's remote or local. The reason we want to have like 2 DIV is because the internal buffering and also and the consequence of that, right? The consumer is always ahead of the drainer. Basically means that maybe this is a better example. Yeah, like the Venice service is a big buffer. It buffers a lot of data before it's write to the disk. So the state consumer sees when we consume, when it reads from the Kafka could be very different from the the end of the pipeline, the drainer sees, right? For example, here's an example. Let's say consumer read and validate the message at offset 1000, right, at T1. At T2, it reads more, 1000 more, it had 2000. The drainer at T3, it'll persist. It's still processing the message 1000, and now it makes a decision that I want to create a checkpoint. I want to checkpoint myself. I want to checkpoint a state. Then it will only checkpoint the state that associated with offset 1000. It shouldn't use the state that consumer sees now, which is probably more than 2000 right now. So there's a big gap in between because of the buffering, because of that. And also, like the drainer is the one that responsible for creating the checkpoint. So I think that's kind of the reason why we have like 2 things. We want the DIV state, which is persisted, is exactly match the other informations that we checkpoint as well, like the offset So we want that to be exactly matched, because otherwise you will have more serious issues. Only the drainer can do that. And I think we cannot only have drainer DIV as well, because the consumer, because of the DCR and other features, the consumer can see more messages that the drainer couldn't see. For example, the DCR will basically, I think the DCR is a feature that if there are multiple updated to the same key, then the consumer will make a decision to drop some updates and not passing that updates back to the ingestion pipeline. So the consumer sees some messages that the drainer couldn't see. It has a better view of the whole picture. So sort of, we couldn't throw any of them. It will be a little bit different when the global RTDIV feature is enabled, but I don't plan to talk it today. It's I'm just talking about how it currently works.
Sorry, it's not clear to me as to why did you say that consumer, like here at least from the wiki, it says consumer DIV only validates like RT messages before producing to VT. So is it happening on the consumer side or is it happening on the server?
You mean this one?
Correct. So I'm assuming it's happening on the server, right?
Yeah.
So you also have a dedupe on the ingestion layer, like just on the consumer? Or like some sort of compaction of whatever you were referring to when you receive like multiple updates for the same key for like whatnot, like you said, some sort of.
Yeah, when we say consumer, we mean the consumption thread, which is the first stage of ingestion.
No, but then like, do you do you try to collapse like updates to the same key? Why would you want to do that?
Well, it's not. Oh, I think it's you are referring to the DCR mechanism. It's not the div through any throughout any message. It's a DCR mechanism that will not passing.
So then why do you need consumer div? Like if you're saying like why not just let the RT message flow to VT and then like have VT div actually figure out, like drainer div actually identify any issues with like the RT messages too?
I mean, you could do that, but it's a big change for the active DCR thing, right? I think that the current way that the DCR, the architecture of the DCR is like that.
No, but then
Maybe.
okay, so DCR I understand. So why is DCR and div connected? Like as in
Oh, so basically
for the RT topic.
The outcome of DCR is some messages that the consumer thread consumes wouldn't be passed to the drainer thread. So some messages that consumer thread can see will not be seen by the drainer thread. So that's like the final outcome, right?
That is okay, but
then that means that means so the RT so say there's no problem in the RT topics, right? Let's say there's no data quality problem in the RT. If the data missing or anything that is caused by our side, by the consumer thread throw away, will be reported because drainer doesn't know about the consumer throws a message out, right? So drainer doesn't know about it. So then it will say, oh, I see a data missing, but it's actually not a data missing because it is simply because the consumer thread throw them away. You see what I mean?
no, but then you wouldn't know if like forget about data missing, right? Like you wouldn't even know if data is missing because you already perform DCR and you only write a full record into VT. So for drainer purpose, it doesn't care if RT has 5 messages that converges into one VT record or if it has one message that converges to one VT message, right? Like because it's only performing on like full records and what is there on VT.
No, you are validating on the whole segment. If you see incomplete view of the segment, then how do you calculate the correct checksum?
But in this case, you can still not calculate the correct checksum, right?
Then, but how do you detect it is real data missing or it's due to DCR?
No. I'm saying even in the current setup, your drainer VT cannot calculate the correct checksum for some messages because it's just going to miss them, right?
VT DIV, you will.
Yeah, the consumer DIV is going to detect that, right? If there's real issue in the RT, then the consumer DIV will detect that.
So let me pause. First, is there a notion of segments in RT topic too?
Yeah.
It is a concept in the Venice writer.
Okay, so let's just say you have a segment of data that's flowing through RT. And then this segment has like 4 messages. Ignore the control messages for now. And the 4 messages after DCR result in 2 messages. And now the drainer, all it sees is it sees a start of segment and it sees 2 messages and then it sees an end of segment and also other control messages. Correct? So the drainer, now how is it actually computing its own DIV? Because it doesn't know of the fact whether the original segment had 4 messages and now it has actually resulted in 2 messages. Not. All it's going to do is I'm going to look at my start of segment that I received and I'm going to look at the end of the segment. I'm going to look at the in-between messages. And then it's going to perform. And the way that it performs checksum at that point of time is not even accurate because what happens is the end of segment, if it is just simply forwarded by the consumer thread, will actually contain checksum of all the 4 messages plus control messages. On the other hand, if it like if it transforms the end of segments to only reflect the to message, then it's a different story, right?
So I think in your example, the drainer DIV, so it'll say, oh, I see something wrong. But the thing is like you don't see the full picture. So even though you think your thought, basically your thought is incorrect. You're seeing inaccuracy. The data missing or whatever arrow that you throw is incorrect.
I think I want to add to that. It's like when you are joiner processing the message, you are seeing the segment produced by the Venice leaders writer. It is the segment created and then produced to VT, but done by the Venice leader. So you will have the complete end-to-end segment with all the message you create. You forwarded by the leader. Leader decide what message to actually write to the VT, right? So in the VT, you have the full picture of that, of the VT side of the DIV, not the RT side.
Okay. So then here, basically then just validating on the consumer thread whether the message that just came from Venice writer to the server is just intact. Is that the purpose then?
You mean the RT DIV?
Yeah, the consumer DIV. Basically,
yes.
consumer DIV seems to do that only, right?
Yes. And only for the leader section. So that's why we need to have a continuous flow to checkpoint and whatever. The next leader come in, they have the previous knowledge of it and continue doing so.
Okay. I see. That makes sense.
Okay. Let me continue. Where am I? Where were I? Okay. DIV state actually. Okay. So next is for the leader double validation thing. That's basically what we sort of talk about, like for RT messages or remote VT messages, the leader will validate. So sorry, the consumer will validate one time, then the data will flow to the drainer, then the drainer will validate one more time. So it's like you have like you validate the things 2 times, which I think for the drainer part is not really necessary because we don't, because of the DCR and other issues, we probably don't even give full credit for the drainer DIV result. So okay, here's a table comparison. The consumer thread and the drainer thread. Yeah, when it do the validation and whether it is going to be persistent, the state will for consumer DIV, its state is transient. We will throw them away. The drainer DIV, it will persist to the disk. And what other Kafka topic they are verifying, they are validating. So that's basically a summary of the this part. So then how we are, so DIV also, the next problem for DIV is like for when you have like consistent state transitions happens for each partition, how the DIV going to behave during the state transitions. So I think I list the main 4 main things. From offline to standby, this happens from the offline, the state transition from offline to standby normally happens when when a server restarts or a new server joins the cluster. So in this case, I think we will see if there's any existing offset record, existing checkpoint, then we load it, the DIV state loaded from the checkpoint onto the drainer DIV. And when it is in the standby mode, meaning that it consumed from the VT topic, then the consumer DIV is not is inactive. So it's every message will just go through the drainer DIV. Then drainer DIV keep updating its own states, checkpoint, all the things is good. On the contrary, if you have a standby to offline transition, yeah, I think today we don't do anything extra. We just rely on the periodic checkpoint to take effect and to persistent the DIV state into the disk. That's how it works today. When the standby to leader transition happens, what we do is like now we need to use consumer DIV now. We want to consumer DIV to have that to take effect. Then in this case, we basically copy all the states, all the drainer DIV states to the consumer DIV, so that consumer DIV basically has a copy. It's a copy of what we have in the drainer DIV. Then it consumes, and it'll keep updating as well. Yeah, and when the leader to standby happens, I think it is okay. We just leave the DIV there. We don't do anything because I think the drainer DIV still has the states. So that's how the current code works. Okay, so any questions here before I move to the next? Okay, so the next topic is that the Kafka log compaction has a lot of impact on the DIV, the Venice DIV. So the log compaction basically it'll delete the duplicate records in the Kafka topic identified by the record key and only keep the latest record. So this mechanism will create a lot of gaps, you can see, because it's removed the old one. You will see the offset record. The offset has a record. The sequence might have the offset may have gaps. The sequence may have gaps. Segment have gaps. I think currently we use a rudimentary method, which is that we differentiate the real data loss versus expected gaps by looking at the log compaction delay settings. So here is how it works briefly. So we look at the incoming sequence numbers and the previous sequence numbers. If there's a gap detected, we will basically look at if there's any log compaction delay settings for the current Kafka topic, and if there is, and if the data is freshly reproduced to the Kafka topic, meaning later than that, then we consider as a real data loss. But if the gap is old, if the data there is already very old, it's before the compaction window, then we just tolerate it. So we use a time-based way to do that.
But log compaction time, how do we configure a log compaction time? Because I'm saying it depends on store, right? Less frequent data, then the log compaction should be longer. Otherwise, this would accidentally clean up the.
Yeah, I don't remember. So we probably get this settings log compaction delay in milliseconds I forgot it's either from a store configuration or from some other configurations. From the Kafka topic configurations. I forgot where is the source of it is.
But it's not cluster.
It's not div configured.
Okay.
It's either the user configured or it's a Kafka settings by itself. We just consume these settings. So I think, yeah, if you understand, I don't need to go to the example here. It's probably easy to understand for the log compaction part. And also another mechanism in div is called the cleanup mechanism. And the reason we have the cleanup is that, as you can see that when the Venice writer, so far we don't see any mechanism that can trigger we clean up the existing states, right? As you can see, as time goes by, we will accumulate more and more state because the Venice writer could restart. There's a new set of the Venice writers, or or whatever. You have a very still Venice writer that starting maybe 30 days, 40 days, 80 days ago. That's not the GUID already. No one is using that GUID. The service died or something. So we will, without a cleaning up mechanism, we will always store those data into the checkpoint and load it back to the checkpoint, and that will cause a lot of memory issues. We have a large memory footprint accumulated in the heap because of the time, and also your checkpoint is going to grow as well. So sorry, no problem. You basically have no bound on the div state at all, and I think the current solution to those problems is that we also use a time-based approach. So we have a max age allows the Venice to expire old state when that is no longer relevant. So and this only apply to the drainer div because consumer div is transient. You use it and you throw it away. So only the drainer div will be stored in the disk. Okay, and also for another point is for hybrid stores, this max age, basically how long we will store your div state has to be larger than the rewind time because simply because when you have a RT rewind, you will rewind back to that point, and you want to the div still store the state corresponding to at least your rewind time. You want you can say more state before that, but you don't want to store less state after the rewind. So because that will cause a gap, right? The gap and the inaccuracy. So that's how the max age came into the picture. Okay, I think that's pretty much I have for the div topic. Any questions? Okay, if no questions, we probably can end.
Do we persist the consumer div state, or do we just simply rebuild?
We rebuild the so okay here we sort the div the consumer div state, it's built from the drainer state. So when the standby to leader happens, we will build the consumer thread using the drainer div. We'll build the consumer div using the drainer div as a basis. We build from the drainer div basically. It's not like from scratch completely. So it has some information there.
Oh, this is actually interesting. So if that's the case, then let's say you in the middle of like actually performing some DCR, your consumer just goes down and comes back, and then you've already written that to drainer, and then drainer actually reads it. How do you now actually sort of consume like what happens if your consumer goes down between start of segment and end of segment?
Yeah, that's a very good question. That's the problem that we want to solve by the global RGDIV project. So I mean, the current solution, I think there's holes here and there. Yeah.
Okay. No.
Yeah.
All right. Yeah, thanks.
Yeah. Okay, so we can end here, maybe.
Yeah.